Draw keys. Everything. Yep. Thank you. Let me draw first. Let me draw. I'll draw, then you can do the task. Okay. Hey class, can you all see? Is it too small? Okay. Can A few things I want to say, which is a good point that some of you raised, which is good. It shows me that you understand and you appreciate it from an engineering perspective, which I want to go through first before we go. Okay, can I ask? What I draw here, F3, F4, is it the same as this?
Yes.
Yes? Yes. Is it the same? Does it make a difference if I draw it here, here, or here?
No.
No difference. Very good. Why? Because connection is the same. Now, to put it in a very finite element perspective, because right, this is a rigid bar, and I'm only giving it a displacement, so you only have 1 degree of freedom. It can only move in one direction. Okay? This whole thing can move in one direction. Okay? And it doesn't rotate, because if it rotates, I need to have a rotational degree of freedom. Correct? It only moves in a translational degree of freedom. Okay? This is important because when we go into beam and truss, the truss will only take a translational degree of freedom. A beam will allow you to bend. Okay, remember just now we say for this, the K is what? The K is E A over L. Can you see behind? Can see? Cannot see, what must you do? Move to the front. Okay? Not my fault. I say already. If you're not, we cannot write this, okay? So we are only giving it a translational degree of freedom. It's not bending, it doesn't rotate. This is a rigid bar, you only move translationally. Okay? Can? Just now I asked who? Thank you. Can you all scan your card? I can't get into the attendance sheet. So I will just assume whoever's got scanned will go in. Okay?
Sir.
Yep.
I never bring my card. legit.
He's the key player, bro.
Okay, I scroll through. They all let me know whether your name is there or not. Okay, you can filter right. Absent. Okay.
So first one.
Yeah, second
Okay.
Third one. Third one. Yeah.
The other Michael also.
Michael Phillips.
Which one?
Michael Phelps.
Okay, no more.
The last two one is
Okay, that's it. Confirm,
last 3, 4.
How much? This one? Alright? Any more? That's all? Okay, confirm. Confirm already, Okay, confirm already. Okay. Need to mark need to denote the degree of freedom. Okay, so you must denote this like this. U 2. This is
U1, U3,
this is
U5,
okay. Notice that this right is your this F1 is equals to your reaction 1. Okay. Note that this F5 is your reaction 2. Alright? Because it is a restraint condition. Can someone do up the overstatement matrix here? Is someone tall enough?
So you cannot just take So you need K1, K3, K4, below that is minus K1, minus K3, minus K4. Right, so it's minus K1, minus K3, not by 2. Yeah, you do, you want.
Oh, you see, actually can come back so long you don't sound like F2, F4.
Okay. How early you want to go back? It depends on how early you want to volunteer. Anybody? Hurry up. Okay, you all try to assemble everything first. I will get someone writing.
put together.其他的都要45。这样应该是。
You all still need this? Before the end of the class, I will show you the assignment tree. Okay, I will search for your assignment tree and I show you what's the assignment tree. Just now what you all see is assignment 2. No, I show the past year example. So you all see what is needed in the assignment tree. You all know like how much work you see. Yeah, correct. Assignment 2 what is like as good as your assignment. It's the 2 and 3 that's actually actually it's the same. This year is tougher than last year. Last year the assignment 2 was assignment 3.
Yeah, how is
Something
it?
very simple. Bicycle frame. This will be a con rod. Assignment is 50%. Assignment 2 is 50%. This one that you are doing now is 10%. But the problem is in your exam there will be one question on this, which is 20%. Yeah, so this one you still need it, even though from next week onward, you will not hear me talk about this. Okay? After next week, not this. Next week I will still spend half a lesson to do this. After that, I will not talk about this anymore. But you're going to come back to haunt you in the exam. Okay? Anybody got any question? Do anybody disagree with this? With this, okay, with this, you will get at least 50%. At least. With this, just drawing this, you get 20%. Okay? Draw, you get 20%. I cannot stress this enough. Like I say, if you work in the engineering world, you will know that everything we do is always through diagram to illustrate. So it's always through diagram, through a figure. I can show you some of my past work. This sort of thing is critical for you to convey. If I just give you a string of numbers, is it going to make any sense to anybody? Okay? Let's look at the question. Somebody asked a very good question, which, like I say, is very good because it tells you whether you are thinking how is this beyond a mathematics. Okay, let's do the question. This is a rigid body connected by ink spring. When I say it's a rigid body, what do I mean? Okay? Hello. When I say it's a rigid body, what do I mean? That means this thing doesn't deform. Okay? If you can, just now we are saying that if it is a cantilever that you can bend, is it rigid body? No. Rigid body means it's entirely stiff. Okay? It doesn't bend, it doesn't elongate. Okay? That is called rigid body. So we have rigid body 1, 2, 3, 4. 4 rigid body connected by 8 spring. Okay? Find the displacement of the 3 body and the force in the spring. Now, I have 1 force, 2 force, 3 force applied to this. I want to determine the spring in each of them. Okay? This question, I am for sure not coming back next week. So you all better listen well. Never mind, okay. Yeah, so now I have the force inside. I want to determine the stress, the force in each of them. Okay? With that, can I determine what is this? First thing, wait. What is n? N, this sort of thing also got people ask me every year. N is number of non-zero digit of your student number. Do anybody don't know what is n? Wait. Who know what is your n first? Who don't know what is your n? N is the last non-zero digit of your student number. What is your student number?
Everything 0. Everything zero, answer zero.
Hey, wait, you're serious? You don't know what it is? The exam will come out like that one. Then you all will not be able to ask me what is the n. You all better think carefully. You don't know what's the n.
It's just like number isn't zero like.
Yeah. How difficult is that? What is the Maxwell number? No. Hey, class. Hey, one, just get your right excited. Okay, just. And okay, you know what is the n? Why do you put your n? Okay, your force, your stiffness. You see that? All multiplied by n. So will you all have the same answer?
No.
All will have different answer. Okay? I suppose that 9 is the answer. If your last digit is a 0, then what is your n? Second last digit. If you put 0, that means your whole thing is 0. Then I also want 0. Okay? I also need to okay, Okay, wait. I need to do this in 5 minutes. I need to do this quickly in 5 minutes. Okay, wait. Let me ask you now with this little matrix, can you, if your n correct, if with your n, you can example this whole thing correct? Will you know what is your this part? Do you know everybody? Do you know how to calculate this part? Yes. Just add a name, correct? How difficult is that? Do you know how to calculate this part?
It's given also.
This part?
Oh my god.
F1 equals to what?
0.
F1 equals to unknown. F5 equals to what?
Unknown.
F5 equals to unknown. Okay? F2, F3, F4. What is it?
Given.
Okay? I want you to assume. Let me think.
Yeah, 对，6人。
Okay, I want you to wait. I'm trying to think. If I cancel this, I don't want to confuse you. So imagine when I do this, right? What will I do? What is the first step you're going to do after you have this?
Fill everything in numbers.
Put everything in number. That's absolutely right. After that, okay, I will come up with I will take away this. Okay, I will take away this. It's still there, but I will not consider this. 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 Okay, because U1 equal to 0. U5 equal to 0. 0, whatever times 0 is 0. Correct? So I reduce my standard matrix, right, to a 3 by 3 matrix. Okay? First. Correct? So I have K1 plus K3 plus K2, 0, negative K2, 0, K4 plus K5 plus K6, negative K5, negative K2, negative K5, K2 plus K5 plus K7 plus K8. Okay, U2, U3, U4, F2, F3, F4. Okay, can? After that, what do I find?
U2, U3, U4.
Very good. You find U2, U3, U4. How do you find U2, U3, U4? Put it into a computer. Use a
Excel.
matrix inverse, M inverse. Okay? Google. Okay? Don't ask me how I do it. Okay? I have this already, yeah? U2, U3, U4 equal F2, F3, F4. Inverse this matrix, M inverse. Okay? Find out U2, U3, U4. Okay? Yeah, correct. It's not really transpose. Transpose is like, let's say the 2.4 matrix, transpose is 4.2 matrix. Inverse means that I flip this over to this side. So it's a U2, U3, U4 equals to inverse F2, F3, F4. Okay? So this matrix. Okay? So you take this matrix, you do a transfer, inverse. Multiply 2, 3, 4 to get U2, U3, 4. Can everybody copy this down? I'm not going to say this again next week. I'm going to the point. So I'm setting out to do this quickly. I haven't finished yet. So this is how I mark your question. So you all must do the same thing. You see? After this, correct, I do an inverse. This is my stiffness matrix. I inverse it to get this stiffness matrix here. Okay? So it's M inverse. Who never use, who is not familiar with Excel? Who is not familiar with Excel? Ask anything, anybody will say they're not familiar forever, correct? I'm not going to get your familiar one, okay? I want you to know, this one is, you don't press enter. You must be something like an alternate shift enter. You look at the sign. Okay? So it's a matrix formation. It's not going to be your normal enter. So I need you to go to YouTube. It's an alternate shift enter. Okay? Alternate shift. Okay? So make sure, I can't remember it's alternate shift or what, but every time I use it also, I can't remember also. Okay, but it is different. It is different. Okay? So you must group the whole thing. If I'm not wrong, it's alternate shift. You need to group the whole thing. So you do this. So you do this, right? Alternate shift.
Control.
Control shift, is it?
Yeah. Now you write yourself.
Control shift enter is right down there.
要什么？应该不用。We don't need to submit the attachment Excel, right? We just write on paper, right? The final answer.
Absolutely right. You don't need to write. You don't need to submit it in Excel. You just give me a number. I will not go and check your metric inverse. I look at the final number. Okay? Okay? Because I just need to change your n. I should get your same answer. Okay? Correct. Control shift enter. You're right. It's control shift enter. I just want to draw your attention to this. So you see. If you see this bracket is different, so it's not going to be an enter thing. You really need to try it out for yourself. And the reason to try it out for yourself is because the exam is going to do the same thing. Okay? So do it in Excel. That's it. Okay? Wait. Go back to the question. Hey, hello. Let me finish. Okay. So now I have my U2. I'm a U2.
这边的话，我直接准备好全部的东西带来这边。
Can anything? No, you all just think up. If you all have some question.
You say the drawing must put inside Excel.
The drawing is an Excel. Huh? So you have hello. Let's not waste our time. U2, U3, U4. I determined U2, U3, U4 already, right? Look at the question. What is it looking for?
U1, U1,
What is the question? Read the question. Find the displacement of free body. So we have done the displacement. After that is what? Force in the spring. How do you find the force in the spring?
KX.
Say up.
F equals to kx.
Ah, very good. F equals to K. We do have an X here in this time.
U.
Correct, it's U. Okay? Now, if I wanted to determine the spring in K1, what is the force?
F.
Come on, right?
Don't wanna.
Lewis, hurry up. I'm trying to make a point, you will see. This is important. Everybody right, I want you to find the force. Denote based on the same denotation. Okay, right. Force in spring 1 is K1 multiplied by this one. U2 minus, which is your spring function that we
Can't
talked
we
about.
just submit back the values inside the big matrix and get the values from the...
If you get it, you only get your U1, U2, U3. You doesn't get the individual force. Yeah, that's why you need to solve for U2, U3, 4 first. Okay? You see? Never mind. It's good. No, this is good. This is where we think about it. Okay? So your force your force in your K1, right? Let's say K1, correct? K1 is K1 multiplied by U2 minus U1. Remember what we said just now? If U2 and U1 have the same displacement, do you have any force? No. But in this case, U1 equals to what?
0.
So what? K1 multiplied by U2. I want everybody to write this for all the spring. Now, give you 5 minutes, then I'll go to the next question already. This is the simplest question. I'm not kidding. Later I'll show you question 5. This is the simplest question.
You say for F1 equals to K3 bracket then U2 minus U1.
Correct. Correct. Alright, very good. Exactly. So you see, just now I say, there's only one element here, strictly speaking, because it's K1 plus K3. Because this is what U1, this is U2, But the individual spring, you have an individual spring force You know, this the spring 1, this spring 3. So there is a different force in spring 3 and spring 1. Why? Even though they have the same relative displacement. Relative displacement means U2 minus U1. That is called relative displacement, correct? It's not an absolute displacement, it's a relative displacement. But why is the force different? Because your K is different.
Same.
Supposedly. Okay? Hey, right! Why you're still staring? Right. This is, don't ask me to come back to talk about this again next week. You're better right. Start to write for all the force inside each of the spring.
So this time we are looking for U, right? So we need to make U the subject.
Which one?
Now
I'm trying to find the force. The force in
force.
spring 1. Okay, no, okay, my fault. Okay. I confused you. My apologies. Okay. So it's not F1. Okay. This is not the external force. This is called the external force. The big F is external force, meaning the force I applied onto the body itself. This is an internal body force. So this is the small f. This F1. Okay. So now I'm going to mark it in red. So imagine the force here. Okay, this is F1, F3, okay, F2, the small internal force, okay, 5, F4, F6, F8, F7. Okay, do you see that? The internal body force and the external body force is different. Okay, of course the internal body force is dependent on the external body force, but they are two different things. Okay?
Like you said, K1 and K3 might be different force, but in this case, it will be the same, right?
Because K1 and K3 is the same, but K1 and K3 could be different, you know, it could be different.
I will write F3 equals
K3 multiplied by U1. Yeah, U2 minus U1. Right, hurry up. Hey, I say, this, do you see that this is where your sign convention come in? Do you get me? If, hey, class, see, this is U2, this is U1. If you get a positive number, is your spring tension or compression? Tension, correct? If I get a negative number, that means what? U2, this is 0, U2 is moving in this direction. You have compression or tension? Compression. So you must put there bracket tension or compression. Okay? Every class does that. Without that, I say it shows that you do not understand. No unit, no sign convention, all will be marked down. This is not a calculus course, okay? This is really an engineering thing. So you need to understand, you need to appreciate the number behind the why do we need the number.
Yeah. Yeah.
So you see, hey, this was raised up, which I thought was very good, illustrate really your understanding. So imagine this one, this element here, correct? So U5 equals 0, correct? U4, if you have a positive U4, correct? It will be what? U4 minus 0. U5 minus U4, correct? So you give a negative U4 multiplied by K7, correct? It shows that for a positive displacement in U4, you will have what type of force in K7? A negative force, which is a compressive force. Make sense? Make sense? Good. Next week, class. Next week, any question on question 1 will be entertained only after 5:30. Okay, that means you need to stay back. I'm not going to address this during class itself for sure, because we have done it already. Okay, I'm not going to waste everybody's time. You want to do it, then we stay back and talk about it. Anybody got disagree with this? Let's spot check. Let's take one and check. Good. Okay, so you must show, like I say, in the assignment, you must write for me compression. Okay, if the number come out to be negative, positive, you must show me tension. Okay? Can okay, everybody note. Then if I circle, then you.
Sorry, can you explain F2?
Yeah, I think you have to.
4 to
U4,
For you.
U4, U2.
For F2.
Good. Okay. Hey class. Wait, hello. One more thing to note, do you see why it's so important to denote in your figure? Do you see why? Because you give me anything here, it could be a right or wrong answer. 90% of the time, not 90%, 50% of the time, we will calculation error. Especially in the exam. If you give me just a string of number, there's no way I'm going to give you marks unless you have something like this. You know what I'm saying? This got no relevance at all without this. Hello. Hey, important this got no relevance if there's no this. Agree? Okay? So if you want to at least have some mark, in case you make calculation error, always draw, always denote. Okay? Every year when I finish marking, I'm required to send a few sample questions, send a few sample answers to RMIT to show that how I have calibrated my mark. So it's not up to only me. I must mark it according to the standard. So you must help me to help you. Understand? Can? Okay, that's it for question 1. Anybody got anything else? 5 minutes. If not, I'll go on to the last one. Then I'll go to the next one. Can? Okay, let's do this first. Let's do this one first. Do question 3 first. Hurry up. What's the first thing we do? So does it make sense? Is it the same as what we have learned just now? Okay, remember what we say? What is your K?
EA over L.
Very good. So what does it mean? Here, do you draw it like this or do you draw it as a string? Okay, because it's the same EA over L. Right. You have 5 minutes. Draw. I'll get somebody to draw.
Sir,
Yep.
the force, is it halfway through only or is it the whole thing?
Very good question. This force, does it go all the way through? Correct? That's a very good question. But imagine this is how to say, that is why I want to try this because in the exam that's how they will do it. They will give you a very complicated type of physical geometry, then ask you to do it like the way that you are. You know how just now what we do here, So the force will only apply where? At the at the node, the force, just like the displacement, will only be applied at the node. Okay, I'll only apply at the node because that is my only degree of freedom. I can't apply it anywhere else because I do not know what is the displacement. I will only apply it at the degree of freedom. How many nodes are there in this 1, 2, 3, 4, 5. Okay? Can? This is why you all think, I tell you what, exam come will give you some weird geometry, you'll be stunned. So you all better try it now. Okay? Actually, once you can translate this into this, half the battle is won. That's why the drawing is always the most important. The drawing is always the most important. Once you get into something like this, most of you can get it for sure. How to translate this into this? That's the question mark. Am I talking to you? 5 minutes. There are 3 more minutes, huh? You all still need this? Imagine next week at this time, we are not going to do any of these things. We'll be talking about abacus already. So you all better take tomorrow to know how to do all these things. Okay? Next week, this time, I promise to not do this. I will assume you will fully grasp this.
No point.
Then write the status matrix for each other. Thank you.
So does that mean that technically F3 and F4 will be zero?
So very, very good question. Think about it. Wait. Think about it. Just now we said how many nodes are there in this model? 5. That means how many U will you have there? How many F will you have there? Exactly. Each node will have, because we are doing only translation, you will only have 1 degree of freedom and 1 force, 1 external force. Okay? That's a very, very good question. Even though we don't apply it, so what is F3 per se? Equals to? Equals to?
F.
F3 equals to what?
0.
F4?
0.
Hey, ask who to draw. Draw. Yes, you are doing it there. Draw and late already, just do.
But you only string 5.
Do the same matrix. And you all must be quick, seriously. Like that, you all are based next week, we go to something else that you all will have enough time to try. I tell you, you're going to have problems. So you all must really do it fast. Next week, imagine this time. Look at abacus, how to do your model, how to do your meshing, how to impose the boundary condition. Totally different thing.
E A over L. E A over L is A.
Right, I say already.
Cancel.
Well, for sure.
A for the A1 equals A like L1 L2 will be E times A1 over L1 then E times A1 over L2.
You all still need this?
We can make the
You still need this? Hey, you all need to take picture, whatever, please do. Next week, we will not come back with this. After 5:30.
No, A1 是 L1 L2 A2 是 L3 No, they already L area A 是 assuming 它是那个 area up down assuming 它是 up down 啦，它是这个是我 assumption 的，这个 assumption 我不懂对不对？OK，我不可以有 blind faith。
我们继续当研究。
Do your individual statement today. I think actually this is quite simple also. We are going to do both questions before we go off. Okay?
So for assignment one, you need to do inside Excel.
Don't need. I show you later. I show you later what the past year did. I just show you the sound, right?
Words.
Huh?
Is that words?
No. You just scan it lah.
Just draw.
Wait like this. Don't need to. Okay, wait. Don't need to type it out. Okay, this is a bad example to do. Yeah. I really don't need the like this. Yeah, correct. Like this. Okay. Then you do your own inverse. You see I don't care one. This one number I just check this one. Okay. So whatever you all do here, you all better do in Excel. This can only be done in Excel honestly, you can't do it by hand. Okay, 3x3 matrix, 4x4 matrix, in the exam you're going to do it by hand, no way. 2x2 matrix is the maximum you do it manually, okay? Then you see hey, hello. Wait, look here. Okay? All have what? Look here
Every answer.
You need sign notation. Okay? All will have. In your engineering document, if you don't have all these things, this is just a string of numbers. Totally, absolutely nothing at all. Most of the time, this is where it gets in the problem. People forget about the sign notation, people forget about the index. Yeah, I mean, in the actual engineering application, that's why you see a lot of failure, all these things. Sorry? Huh? Don't need. Hey class, listen hello. Don't need to attach the Excel file. Don't attach the Excel file. Same in assignment, same your exam. You do your own Excel, you come out with it in your exam, you take a picture, scan it, send it to me. Yeah, of course there is an attachment. This one you attach in the canvas. Question. I can't mark whatever I can't see. Okay? So you want to scan, better do a good job. I have people that come up with a low resolution. Same problem. If I was to send this to RMIT, they are not going to see it. How can I award mark for that? You know what I'm trying to say? So you all want to scan, do it properly. I'm sure you all can do a proper job in taking photo, right? So make sure you take properly.
Our exam was like
Exam also got time. Of course, 3.5 hours.
I thought it's face-to-face.
Sorry?
I thought it's in class.
It should be virtual if I'm not wrong. For your exam, this one, no. Last 2 years is virtual. I'm not sure. Hey, wait. I'm not sure. Okay, but last 2 years because of COVID is virtual lah. Okay. Why? What's the problem?
No,
No, I mean, you said you're recording Excel and so.
No. I said you gotta put in Excel, but you do not need to send me your Excel table. You know what I mean?
No, but in Excel,
You don't send me Excel lah.
just drop the matrix and then let's.
Yeah. This is like I said. Hello. This is a engineer like we do it like how you will do in your everyday job. You know what I'm trying to say? Oh? Hey, hello. Are you all done? Can we take a look at this? Oh, wait. Let's just go through this. So you see, look at this. Okay, never mind. Yours, next week, I expect you to finish question 1 to 3. Okay? Next week, when we come back, I'll spend half a lesson to do 4, 5, 6. Okay? It's not going to be easy. After that, you all will see 4, 5, 6 is not going to be easy. That's why I need half a lesson. I can't afford to cycle back to question 1 to 3. Okay? Do you all need any help? Do you all need any clarification for this? Can you all, let's put it into the big matrix. So after this, what do you all do? I assemble them, alright? Which is easy. Because all this is in linear, alright? Sorry, not all this in linear, all this in the series. Okay? All this is in the series, okay, so it's easy. Okay, so if you what, it will be K1, negative K1, negative K1, K1 plus K2, 0. As I'm assembling the global matrix, okay? 0, 0, 0, U1, U2, U3, U4, U5, alright? Equals to F1, F2, F3, F4, F5, right? Negative K2, negative K2, K2, then I add in the third matrix, which is plus K3, correct? Minus K3, minus K3, K3. Plus K4 minus K4 minus K4 plus K4. Anybody don't agree? Hello. Can? Yes. Now, what are we going to solve?
3 by 3.
Very good. First, very good. I'm solving the 3 by 3 matrix. This is equal to 0. This is equal to 0. Correct? So I'm taking out this and this and this and this. Alright? Okay? Do I take out? Okay. After that, what else can I do to simplify this? So So I'm taking out this, correct? I'm taking out this, I'm taking out this, correct? So what is F2?
200.
Equals to n times 200. Agree? What's F3?
0.
Huh? F3 equals to? F4? Do I take out the third and the fourth row?
No.
No. Why?
U3,
Why? Hurry up. Somebody else say something. Quickly.
U3 not equals to 0.
Sorry?
U3, U4 not equals to 0.
Very good. Very good. Okay? Because U3, U4 not equal to 0. That's why we can't remove that. Agree? So it's a 3 by 3 matrix. Okay? Understand? After that we solve. So from this we solve. For
因为 based on 它的 diagram 只有
U2,
一个 S
U3,
F2.
U4. Alright?
So
Read the question. What are we looking for? First is the
displacement,
node displacement, followed by.
element stress, and
So how do you find what is your element stress?
K.
So this here, now just now the first question only have one part, find the stress. The two part, find the displacement and the force, spring force, correct? Which we say previously, right? You know just now we say the spring force equals to what? F1, F2, F3, F4, correct? So this is the first thing to do already. There's three parts to this question. Second part, how do you find what is
Find
your
K.
spring force?
EA over L.
Before that,
K U minus one.
okay, F equals to,
K U minus one.
let's say F1 equals to what?
K.
U2 minus U1
K.
K1. Okay? Hey, just now this one never denote the
Direction.
U2. Okay, you must denote this. Okay? So this is the force, spring force, as per the first question. How do you know what is your stress?
Oh, me. You mean the second one?
No, after you have done your spring force already, right, how do you know what is your stress? So the stress equals to what? Just now you say the answer already, is A over L, correct? So your stress, sigma 1, right? Okay? Is equals to F1 divided by A1. Correct? Do anybody do understand this?
Force over area.
Huh?
No.
This is stress, your stress. Sigma 1. What is your Young modulus? Recap. I'm not going to accept if you tell me you don't understand this, you don't know about this before that. Your Young modulus, right, equals to what? Your stress, sigma, divided by your strain, epsilon. Does it ring a bell? Yes? Correct? Who don't know about this? Okay, so it's the same thing. This is not a elementary course. So you're supposed to already know some of these things already, okay? Okay, so sigma 1 equals to F1 divided by A1. Okay? Okay? Some people do it otherwise, which is also okay. Because just now I say, correct? E equals to sigma divided by epsilon, correct? Some people do it the other way, which I'm fine, okay? The other way to do it is, you know what is my E, I know what is my epsilon. Epsilon is what? Is my deflection, which is U1 minus, U2 minus U1 divided by L. Also can. This is your epsilon, correct? This is your epsilon. Correct? So you want to do it this way, mathematically it will be exactly the same. Fine. Okay? What else are we missing? There's one more thing we're missing. What's the third thing? Hey class, what is the third thing we need in this question? What is it asking for? Hurry up, hurry up. Support reaction. So what is the support reaction?
我记得是这个吧，我记不清楚。
Correct. Just now we said
这个是 U2
that is your
minus U1 over
F1.
times E.
F1, the capital F1 and F5. And we say that just now, but actually it's up to you lah. I will normally put this as R2, R1. Okay? So how do you know what is your R2 and R1? Huh? Sorry? R1 is not equal to R. Wait, never mind. Wait first.
U1 times E. I think 我懂这个是什么。
What is R1 and R2? I say just now we remember we cancel this out. It's not because F1 and F5 is 0. It's because U1 and U5 is 0. It's not because R1 and R5 is 0. R1 and R5 confirm you have something because there is a reaction force there. The fact that you restrain it, then you can have a zero displacement. But the fact that you have zero displacement for sure there won't be a reaction force. Agree? Remember, we go back to our original.
Stress over.
We go back to our original line element. Look at this line element here.
忘记了。
One line we learned today what? For U1, okay? If I have a spring, okay, I impose a U1 displacement at node 1. Correct? What is the force I need? I need the F1 equals to K1 multiplied by U1. Agree? In order, let's say you have a spring here, I fix this. I push it. For you to have a displacement of U1. What is the force I need to apply? U1 times K1. Correct? What is the reaction force?
U1 K1.
Negative U1 times K1. Exactly. In order for me to have this force, it must be the opposite and equal force. Agree? So for sure, there will be a force there. But F1 and F5 is not going to be the same. Okay, they will be definitely different. But just as here, this force, the summation of the reaction force, will be the same as your external force. Agree? The summation of your reaction force will be the same as your external body force. Okay? So how do you do that? How do you determine the reaction force there? Huh? This is not so complicated. But I just told you all just like 2 minutes ago. There. The one line element one.
Is it about summation, then summation of all forces, then negative is?
You can do that. Actually, you can do that. That's how Pythagoras will do it. But in our case, we cannot do that like that. So what you will do is you find the same thing as what we have here. I have my displacement here. Assuming this is fixed, correct? I do it back here. The displacement of this U2 minus U1 times K will be your reaction force. Right.
So it's R1 equals to K1 U1 minus U2.
Correct.
Oh.
Okay? So your R1 equals to what? U2. Do we need to minus U1?
Yes. No.
Why?
Zero.
Okay?
R2 equals to K4 U4.
Okay? Can? That's it. Last question. Then we are done for the day. You want to still need this?
This is the R1 negative and the R2.
You still need this? You still need this? Don't think I.
No, I mean,
Let's do the last one. Can we just focus on the last one? Hey, hello. We have 10 minutes. How much you want to do for question 2? How much you want to do question 2? Draw. Class. How are you going to draw this? How are you going to draw this? This is actually a very good example. I deliberately skip this first because I want to see this first. Then you can go and do this. Okay? How are you going to draw this?
Another spring.
Very good.
Another spring.
Yeah, so imagine same thing. If I have the side formation, I take a. Let me take the second question. Yes, agree. Sure, agree. Very good.
Left to right 是 positive.
Okay. Wait. Sorry.
But I mean 你可以
Hey,
F3 先，你 just 不要管
Class,
这个 F 先。
good point, typo. Okay, so this should be positive and this should be negative. Good point. Okay? Why? This should be negative. So imagine if I have a positive here, right, the direction force must be negative. Okay? Imagine I have a positive here, right, the direction force will be positive. Makes sense? Okay? It should be. It makes sense. Yeah. So imagine I have a positive force, a positive displacement here, right? The direction force will be what?
Negative.
If I have a positive force in this direction, what is the direction force here? Also in this direction. Okay? Okay, hey class. Draw. Minimally, if you draw it, it's half the better one. So I want everybody to at least draw this. This is going to be very fast. This is going to take 5 minutes.
Wait, so then you just now said it's the opposite of the force, right?
Yep.
Now it isn't the opposite anymore.
Yeah, it is. The reaction force is opposite. What do you mean? This is coming in, right? So this reaction force will be the other way around.
Then that should be negative.
Yeah, that's why this one R2 will be negative. R2 will be negative.
Oh, because it's progressive.
Mm. Sorry?
So the force is
Okay. Hey guys. The reaction force, the reaction force, think about it. Okay? We will come back to this next week. The reaction force, let's think about it. But can you all do this first? Hey, hello. Are you all doing or not? I'm not going to come back to question 2 tomorrow, next week.
like this, you know, it's like it's compressive.
The diagram says it's
Actually, both sides will
Very good point. Hey class, actually that's a very good point, but never mind. Later I will explain that. Doesn't matter. Okay? Your good point was asked. Yeah, I think I say. Okay, see, just now I say, correct. How many nodes is this in this model? 3 nodes, correct? U1, F1, F3 now is what? Negative. Okay, it's a negative F, a negative N, N times 10 kilonewton. Okay? When we go next week, or when we go on, the third week, all this kilonewton, newton, millimeter, meter become very important, and you will see why. So that is why this is all become very important. I want everybody to quickly draw, then we shall do the same thing, at least to cover the entire question 2. First and foremost, before I say, hello. Let's look at this. Read the question. Find for the spring and bar assembly. Determine what? How many things you need to find here?
Force.
No, first,
Displacement.
always find what? It's always a U. It's always no displacement. Okay? No displacement followed by force
Reaction.
and the reaction.
Stress.
And so in your question, every time people don't read the question, okay? If in this question you must give me how many things? 4 things. Question 3, how many give me? 3 things. Correct? You don't have confirm data one. Okay? Confirm with data marks. That's why it's important for you to read. So everything you should already know. You know your spring force, you know your stress, alright? Displacement, reaction, everything you know. Sorry? Correct. No, but you know what I'm trying to say. So you denote the same diagram as per what we did just now. It doesn't change anything. It's only when your F3 comes in, right? It's a negative F3 now. But you do it exactly the same as just now. It's always left to right positive, left to right positive, doesn't matter. Okay? During abacus, I can show you this become very, very important. All these things become actually important.
Your US arrow, same person.
Still same. Yeah. That's why it's important. At least this is what you see. That's why our notation is become important.
Just put everything positive first, then I just yeah, F3 is go this. F3 I put go this way, but when you write F3 minus F3 equals to M. And if you want to put negative here, maybe negative yeah, do first.
Then put it together, assemble it together. Can I see your diagram? Yeah, the denotation. I say the denotation where it's positive, the arrow to demark the point.
Because it's not fixed to it.
Same thing, imagine if this is the actual condition, you expect things to what? Imagine that push this right, this will what? This will flip out in in real life, correct? This one you will see some sort of lateral torsional buckling, the type of thing going on. In this case, no, because we are only applying a single degree of freedom, which is tension or compression, so it will not flip out. So, but then that's why when it comes to your exam, then you need to tune it a little bit. The exam will only be translation. Confirm will not give you rotation all this because we didn't cover it. So you just know that it's always translational type of spring. We're only doing translational type of spring here. Okay? You all copy down already. Let me find the assignment 3, then I'll show you all. I said I'll show you all, right? Oh, you all don't want to see. You all want to, are you interested? Sorry. The assignment is, this year one is more complicated than assignment 3. Then what I'm going to show you. Hey class, see ya. Hey, here you must put it as U1. Okay? So you must denote it this way lah. So if you are telling me that this node that can move in this direction is positive, okay? This node you must show me is move like this. U2. Okay? Can? Same thing here. This you must show me U3. You do not need to show me the force because the force and the displacement are correlated. Okay, you just show me that one side, left to right, is positive. That's all you need to show me. Okay? All same direction. So that's why I say that F3 is in a negative. So it cannot be, this force cannot be in the other direction. Okay? It must be like this. Okay? Can? You know what's your F, right? You know what's your F? Correct. Here, back to here. F1, the U1, is it 0? What is the matrix we are looking at here? Is it a 2 by 2 or 3 by 3 matrix?
2 by 2.
It will be a 2 by 2 matrix because
U1
is 0. Okay? And I tell you why, class, listen. Why it must, just now you know I keep on telling you all about the 3 by 3 matrix, all these things, how 5 by 5 come 3 by 3, right? But I want to let you understand one thing. The reason why it need to be a 2 by 2 matrix, why? Because F1 is what? No, it's not 0. F1 is unknown. So even if you inverse, you can inverse a 3 by 3 matrix, but you do not know what is F1. You know what I'm trying to say? You know? Okay? F2 is what?
F2 is unknown. 0.
F2?
0.
F2 is 0. Very good. This is the external body force. How many external body force do you have here? 1. Okay? F3 equals to?
Minus F.
Okay? So it must be a 2 by 2 matrix because F1 is the unknown. Okay? U1 equals to 0. Okay? So can you solve for this? You can solve by hand if you want to. No need lah. Do Excel. Wait, let me see what else I want to say. Okay. So what's the 3 thing you what's the 4 thing you need to do here?
You know, just simplify.
With this, you have solved number 1, your displacement.
Just 换 as 一个 negative number 就好了，你不要管
Correct.
positive
Number 2, what do you need to do? Spring force, correct? So the spring force, same thing. This is your small f1, your small f2, correct? Small f1 equals to what?
K1
K1 U2, correct? Okay, f2, okay? What else do you need to calculate? Reaction.
Second row first column.
And last one, stress. What's your stress?
Yeah, 应该是
F over A.
Huh?
F divided by A.
F,
Yeah,
correct?
应该是那个
Oops.
positive. Sorry,
Yep.
I think the matrix, right? The first column, the second row should be minus K1.
Very good. So it should be this, A class C, minus, minus, minus,
Oh, yeah.
minus.
Yeah.
Okay? Always balance.
因为 I think 自己
To
做
be
那个
symmetrical is
sin
to be able to inverse, it must be symmetrical, right? Okay, take note.
因为他那边他写对了嘛，这边没有写，所以我刚才看到边的时候，我就这边没有写。
Okay? Yep. Okay, yeah, same.
So number 3, what you ask that reaction?
RxN is just the
reaction.
short form for reaction. What is the reaction?
Negative F1.
Huh?
Negative F1.
Negative what?
Spring force 1.
Compression.
Where is F1? Where is F1?
K1 U2. K1.
Again, think again. What is reaction? I always say the reaction force is equals to the external body force.
Is it the
Negative
first spring plus second spring?
Is equals to the negative external body force. For sure.
No, but it's okay.
For sure. Negative F equal to negative F. For sure. Correct. External body force must be equal to internal body force. Just now it's because we have 2. Now we have only 1. Agree? Yes? But it's a good thought, and you're don't get discouraged by me. This sort of thing, right, is part of the process for you all to think about it, which is actually very good. You all start to ask questions, what is this direction, what is that direction? It's for you all to think about it, okay, which is actually very good. Think about it some more. Okay? Hey, class. Wait, when I say, I'm not sure whether I better don't do it this way. Later if you have more problem with that. So it should be what? It should be negative F. You get what I mean, right? Because this is negative F, so it's a negative F. Agree? Because the force will be in which direction? Positive or negative? The force is positive or negative?
Positive.
If I exert a force in this direction, this force must be what?
Positive.
Must be moving left to right or right to left?
Left to
hurry up.
Left to right.
Moving to, if I have a force pushing it down, this reaction force must be what? Left to right. So it will be very good. I promise show you the assignment 3 last year one. Okay? This This is last year. This year you are doing the con rod. Okay, stress concentration, all the corporation. Last year, assignment 3 is just doing a push it up, the stress here. Wow. Okay, take a look. Hey, your position, just give me, bear with me 3 minutes. Just bear with me 3 minutes. Hey, hello. Okay, so they are doing this. So you need to do a plate model followed by a solid model. Okay, plate model. So you come up with a plate model. What is the stress here? I told you just now the sign conversion is extremely important. This is the meso stress, this is the scalar stress. This is the S11. So this is the S in the X direction. Okay, if you see here, I push it up. Here will be compressive. Here will be positive. I will mark all this type of thing, and you are supposed to, you can see the explanation later. That's why it comes in. Okay, this is you get what I say. Imagine I push it up. Here will be what? Here will be compressive. Here will be what? Tensile, compression. Okay, all these things. The sign convention is important. Okay, S22. Look at this. S22 what? S22 is what? This is a stress in the vertical direction. Same thing here when you have a rotation here. Here will be one positive, here will be one negative. Alright? All these things I expect you to elaborate in your report, which is what done here. Okay? Okay, then you see all the stress that comes in, your plane stress, your plane strain. This is a shell model. I just want to remember we said this could be represented what? As a beam, as a plate, or as a solid. Alright? So after that they go on to do a solid model. Okay? A solid model with what? With refinement to the design. That's why I said this is important for you to learn your software on your own. After that, refine the design. How do I refine the design? I do a curved cantilever beam so I can save, so that I can increase material only when the cantilever moment increases. Okay, which you're going to see the con rod even more. Okay, refinement of the design. Then after that, cut through. Because why? Because I'm only interested in the bending stress in the thickness direction, correct? So actually I can remove some of the material here. Okay? So this course is going to be extremely applicational. Okay, actually by right they also you're supposed to come up with what? A hand proof for this. How do you know your software gives you the correct result? What you're doing today. Prove by first principle, this cantilever moment, cantilever arm, force applied, bending stress here can be checked against your model. Okay, it's not just simple punching through the numbers. Alright? Okay, thank you everybody. That's all for you. I expect everybody complete question 1 to 3 next week. Okay? Next week onwards we're going to do 4 to 6. Okay?